Hello and welcome to TidyX episode 24. All right, my name is Ellis Hughes. I'm a statistical programmer. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and I do data analysis in sport. You can find me on Twitter at OSPPatrick. You can find both of us on Twitter to support this screencast at tidy_explained, or you can email us with questions, comments, things you'd like to see at tidy.explained@gmail.com.
All right, yeah, so TidyX is a screencast that's going through and trying to explain how our code works. We typically go through TidyTuesday submissions because we think they're great examples of ways people are using R to explore data, visualization, and those sorts of concepts. So the TidyTuesday data from this week is on plants in danger. So it's plants that are in danger of extinction or are extinct in the wild, but are still in captivity, I guess. Plants. I don't know if it's captivity. Sure, we'll call it that. Why not?
Neither of us are biologists.
No, as you can tell. But it was a fun data set. We had some ideas on how people could approach it. Really artistic visualizations this week, I thought. Like they were very, very clever, very interesting to look at. One that we thought was actually really interesting is the one we picked, obviously, to go through this week, is from Jared Braggins. And so he went through and created this waffle plot showing what are the causes of extinction for the various plants in Africa that's going on right now. So this is historical data, so showing from I think early pre-1900s till now.
Yeah.
But what are the causes of extinction for the plants there? So we thought this was a really great way to visualize it. You can really immediately understand what's going on here. He on the left here, he's got just the full waffle plot showing the various percentages or various shares of the causes, but then he broke it down into 6 different extinction causes here, where the actual share was highlighted. Everything else was grayed out. So I thought that was very creative, very visually appealing, and you immediately understand what's going on.
Yeah, this is a cool. I've never made a waffle plot before, but I've always wanted to.
Yeah.
And so this was a good opportunity to do it. I do like. You see these a lot right now, especially with the whole COVID-19 thing in media reports. Scientific America article, I think, had something about Bayesian inference and basically a positive test in COVID and how that gets updated and or false positives. And you'd see like something like this, instead of circles, it might be like little pictures of people where it shows a population of 10,000, and then it highlights that, maybe 20 of them have the disease, and then how many of those might be false positives. And I always thought these were cool ways of kind of showing people what counts actually look like.
Mm-hmm.
So I think this was awesome, and going through this really kind of helped us target ourselves at doing a fun kind of shiny app that we'll work through after this one.
Yep. All right. So Jared shared his code right here, which is available on his GitHub page. So we took that, pulled that down into our R session. So we'll open that up now, and we'll go through and explain how it all worked. All right. So zooming in. So hopefully this is clear for everybody. I guess let us know in the comments in the future if I need to zoom in more. All right, so because I can't correct that now. All right, so the first bit is, as usual, is loading the libraries you're going to be using for your analysis and visualization. So tidyverse, data manipulation, using library Waffle, but you need to be careful with this one because this is installed from GitHub. So this is from hrbrmaster. We've mentioned him several times. He's just prolific at generating like so many cool packages, and so this is no exception. But you need to make sure to install it from GitHub, not from Cran. Just one thing to note as we went through that. ggtext, which is from Klaus Wilkes and his team to do some cool data manipulations to ggplot. Library here to help with paths. Patchwork to do manipulations of the ggplot objects, and then extra font for nice fonts. So he's got that all set up. So let's run that so I don't forget to do that. All right, so then he imports his data using the slug there. You can also use TidyTuesday R. I mean, that's my preferred method, but once again, I'm biased since I wrote it. Then he goes through and uses view to just take a quick peek at the data. So this is capital V in view. You just execute that, and it's going to open, if you're in RStudio, or even in base R's GUI, it'll open up a window that allows you to kind of look through your data set here and kind of get a peek at what's going on here. So you can look at the columns. So this isn't like a summary of it. This is your actual data that you're going through and
Basically,
looking at.
like if you were looking in Excel, you could sort the columns and everything.
Mm-hmm.
The only thing is if you are in base R, and maybe it's just me, but if you have a big data set, I have had base R crash when I try and view them. Never in RStudio, only in base R. So
I think it's because they will limit the number of rows and columns you can actually view. So
Maybe.
here it's showing you 1 of 10 of 6,000 entries and 8 total columns. I know I've had cases where I've had like 100 columns, but it'll truncate it at 50, and I have to manually go over. So I think that's probably what's going on with that. RStudio is doing some clever stuff in the back end to make sure we don't kill it.
You could also do like threats and then pipe head, pipe view, and then only get a small subset if you didn't want to pull the whole thing in.
Exactly, which is a great way to take care of it as well. All right, so then he takes the threats data set, uses a filter to remove or to keep only the cases where the continent is Africa, so he's only keeping African plants, and then also only keeping cases where they're threatened. So there must have been some other faceting or other values there. So he's subsetting to keep those.
It was a long data. It's threats is a data frame that's long. So basically every possible threat is a row for Africa, and it's binary. It's either a 1 is a threat or a 0 is not. So he's just getting rid of all the things that were not threats.
Gotcha.
Yeah,
And then he goes through and does a group by continent, so that in this next step it keeps continent, where he does then a count by threat type. So now you're going to get a single row per threat type and the number of times that threat type appeared in the data set now that the filtering has been done to only keep each case of it. So then we can take a quick look at that. So you can see we've got Africa is a continent, the threat type, so the various threat types that exist, and then N, which is the number of times that appeared in the data set once it was filtered down. It does an ungroup, so as you can see, this is a grouped data frame there. That can cause issues later on, so you'll want to remove that. And then goes through and calculates the percent, so the number of divides the threat count for that specific threat type out of the total, so you can turn it into a percentage. And then this we thought was pretty interesting here, his approach to this. Let me zoom out so it looks nice. But this looks like it's essentially an FCT lump or factor lumping, where he's only keeping the top 5 threat types. So agriculture and aquaculture, biological resource use, all those, and then any other threat type is turned into other. So this...
And he wraps it all as a factor, because otherwise case 1 was going to kick it out as a character.
Mm-hmm. So this is like a modified FCT lump. At least the way that I understand an FCT lump works, you can't use it against a data set like this, where you're trying to lump it by N. Correct me if I'm wrong. Please put a comment down there if I am saying something incorrect here. But FCT lump looks at the number of times each individual factor shows up. At least that's how I understand it's used.
I think that's correct. Every time I've tried to do something like that with aggregated data, like that data set you have there, it never works. I usually write like a series of if-else statements to get me, if else call it this, if else call it that, if else call it that, otherwise call it other.
Mm-hmm. So this was a way to get around that. So I thought that was pretty clever. Patrick, do you want to take us through this next step here?
Yeah, so once he's kind of got his makeshift FCT lump data set run there. He then takes his threat data. He's selecting the two columns that he cares about, which is the threat type and now the percentage. So basically, again, threat type is going to be 5 different threats and then everything lumped into other, and the percentage of threat types that those correspond to. And then he's going to summarize and sum these all up so that they equal 100, particularly for the other category, I think is what he's trying to get to there. And then he's going to create a new column, which is called threat type. So he's going to overwrite the previous threat type, and he's going to do an FCT reorder. So he's reordering threat type by the percentage that we observe for each of the corresponding threat types. So the percent contribution of each of those threat types to plant extinctions in Africa over the time period observed in the data.
Yep.
And so here we are.
So
we should, the 32, 23. So if we do sum of threat data percent type, we should be able to get 100 is 100%. And so now, when this is valuable because when he goes to plot the waffle plots, that percentage of 100 of that square grid, that percentage is going to define how many of those colored dots correspond with the specific threat type that he's highlighting.
Mm-hmm. Cool. So now he goes through and works on setting his theming for the plot itself, to making it look pretty, make it look nice. So setting the font family to be Century Gothic, the text and axis colors to be white, a background color to be this hex code. I think it's like a dark gray. The plot color itself to be black. So then he goes through and creates his own styling theme where he theme object. So he uses theme. He sets the text to use the font family he wants. The rectangle, I believe that's the area around the plot, to be filled with the background that he defined. Define the plot background is the that gray there as well. Plot type. It's just basically a lot of theming as you're because it's within theme. To define the title, the subtitle, to use the element text there. So boldface, HJust of 0.3, so moving it slightly over. Plot subtitle, also a size of 14, slightly moving it around as well. Plot caption, setting the size and the color. So it's a lot of theming, and then he also does a lot of blanks. So he's removing the borders, the grids, the text or the title X or text X and Y, so the X labels, the ticks and the lines. So he's just kind of clearing it out. So it's kind of like a theme void. He doesn't want it. Remove theme or legend.position equals none means he doesn't want to have a legend in there. And so it's just like cleaning it up, remove a lot of those things. But then he actually does an interesting thing here where he's now going to set his theme across all of his plots using theme set. But what he does is he uses the basic or the base theme classic and then adds on his theming. So that way his custom theming will now be applied to everything, but he didn't have to define literally everything. If he liked a lot of what Theme Classic was doing, and what he clearly changed it a fair amount here, he can define all that styling within this one chunk here. So he's adding the two together, and it's now going to be applied to all of his plots.
Which is super handy. He's way smarter than me. I've never thought to do that.
Yeah.
I like it, though. It's like super handy. So I'll definitely steal that.
Yeah, so let me go through. Did I just rerun that? Let me just make sure that I don't accidentally mess things up there. All right, so that was just running everything. Then he's got a bunch of colors that he's defined. These are the different colors he'll be using for the different threat types there. And then any call filter is another hex code for another color that he wants to be using. Sets the R to be 4. This will come up in a second. I believe this actually... Where does this come up? No, I guess it comes up later. So R equals 4. Then he goes through and starts creating his plot. So what he does is he puts his data in there. He sets the fill, so the fill of each waffle piece will be based on the threat type, and the number of times that's listed will be based on the percent. So then you're going to end up with a nice square where it's going to be colored by the threat type and the number of times it'll add up to 100. Now he uses geom waffle, which is from the Waffle package from hrbrmaster, where now he's defining how the waffle plot's actually going to look. He's going to have 10 rows where each box is now going to be size of 0.5. They're not. I guess the color is going to be the outside of the coloring. Sets the radius to be a point or 9 units of point. Okay, sets the height and the weight, so the how large the boxes are in the waffle, and flip equals true. Not quite sure what that does. I guess that's kind of just setting the order for things. Then he's gonna set the coloring. So this is where all those colors that he defined earlier for each of the threat types, or this is where they're gonna go. And then he's gonna use this function here where he's setting the alpha. So how clear these colors show up. He's setting them to be a third. So if you look at his plot, the left side plot, it's a lot more muted than the other plots because this is just kind of showing overall this is how they look. He sets his labels to be title, extinct plants, subtitle, what are the causes, and adds a little bit of a margin there. So he's created P1, so you can take a quick look at that. And
there it is.
So here we go. So what are the causes of extinction? So here's all that information there, and that's the one that was on the left. Patrick, do you maybe want to take us through this second plot here?
Yeah, and the second through I think there were 6, 3 by 2, or 2 by 3. So the second and the ensuing 5 plots after this are all the same. The only difference is that he's going to color the specific color he wants for the defined threat. So going through this P5, we use again threat data. All the same deal here. So we want to fill by threat type using the values that are the percentage. So the corresponding amount out of 100 that this threat type represents. We're going to use the geom waffle. It's all the same information here, indicating that we want the radius to be a certain size. This gives us that circle type of look that he had in his plots. And then the scale fill manual is where it comes in, where we saw that you can see that he's got 1, 2, 3, 4, 5 of the values set to call filter. So that's going to be that grayish color. And then the 1/3 in the alpha gives it a little bit of opaqueness, a little bit of kind of blunting of the color, so it's not as edgy. And then the last color at the bottom there he keeps is going to be the one that corresponds with the color from the graph that we just made. So that's how they all kind of stay in order as he plots these on the grid of the sheet that you wanted to look at. Then he writes his labels in. So he's got, this is going to be the plot that defines agriculture and aquaculture risks, or threats rather. And he uses a little bit of HTML code here, which he can pull from the GG text package. So this is where he's kind of specifying that font size. And he's got 32%, which is the percent contribution of threats that agriculture and aquaculture had. And then finally at the bottom there, he has a little bit of theme stuff. I guess that theme stuff could have gone in his defined theme above. But he puts it in here. He's basically saying, I want my plot title to use this element markdown. HJust is basically moving it on the horizontal. He wants it to be a size 10. And the color is text color, which he did define above. And then if we scroll down, we can see that he has a plot defined for every one of these. So now biological resources, if we go to the scale fill manual, we can see that now the second from the bottom is defined, and the one that below that, which represented aquaculture and agriculture, is now turned to gray. Same thing, if we scroll down, the third plot in scale fill manual is the one that has its key definable color. And then we scroll down one more time. We'll see the second plot is the defined color within scale, fill, manual. Everything else is the same. The only difference is which color dots are being colored in, and in the label, the percent contribution. So he's actually defining that using that little bit of HTML code. And then if we scroll down 2 more, we get the two final kind of plots. So energy production and mining is the last threat type. And if we run everything all at once, we have all of our plots built. And this is where he's going to plop this all into Patchwork, which we've talked about a whole bunch before, and we've had Thomas Mock on before, this is just a super easy way to organize your plots in a sort of grid-like manner. So he's basically taking the P1 plot and he's putting that into its left side margin by itself. Then he establishes that vertical bar, so everything else on the right side of this vertical bar is going to go into the right side of the plot grid, and the parentheses are defining his rows. So he's saying I want P2, P3, and P4 to be laid out in a single row, and then the little slash sign there is saying now below that I want P5, 6, and 7 to be laid out in another row. So that's how he gets that 3x3 theme on the right side of his plot. His plot layout, he keeps the guides. And then the plot annotation is basically just giving it sort of this caption that says who made the plot and what the source of the data was.
Cool. So we've got all that. He then, so we'll run that. What happened? Oh, did not execute. There we go.
There we go.
Getting ahead of myself again. All right, so here we go. So let's view this plot here.
No.
Okay, well here we go. So this is it showed up a little bit. Oh, it's probably because I'm zoomed in.
Oh yeah, good point.
Zoom. Give my computer a second. Oh.
That's like a zoom on a zoom.
Yeah, let's.
Like a mega zoom.
There we go.
Hey.
There we go. All right, so this is exactly what he created earlier. So now we know how each one of these was a single plot where he patchworked it together. This is the left-hand side that has this height is 2 rows.
Yep. And you can see the how he used the HTML from GG Text to establish the percentage contribution of each threat type. They're bigger, they're bolder. That was what he was doing with that bit of code. So.
Yeah, that's a pretty cool way to go through and patchwork all this information together. It's a great way to look at it all. I know I had a lot of fun. I learned a lot. I hadn't had a chance to use Waffle myself. Like Patrick, I've wanted to use it, but I haven't had a use case for anything that I've done at work or any of my personal stuff. But now we got to go through and kind of get a better understanding for it.
And now we have a use case, so we can go through our use case for Waffle, right?
Yep. So thank you so much, Jared, for letting us go through and explain how your code works. If anybody has any questions to us, post in the comments below. All right, so now we're going to hop over to our approach. So let me quickly restart my R session, Control-Shift F10, because I'm on Windows. Restarted my R session just to clear out everything so we don't get impacted by what was done earlier. Let me zoom back in. Oh, wrong way. There we go. Yeah, you can't see that? All right. So now we're going to go through and explain a use case we came up with a Waffle. So we're using our Markdown. As we've said, we like the format and the way it flows, and we've got chunks that we can just kind of click through and run. So we're using Tidyverse, ggpub-r, which is Patrick, I think, has a better understanding of it than I do.
We'll use that to basically turn an R data frame that we create into a table that we're going to then use to plot onto a grid so that we get numbers and a visual. So we'll show how that works in a second.
Janitor for general cleanup, rvest for web scraping. Yes, we're doing that again. Then we're using GG Waffle from Liam Gilby.
Yeah.
And then
A different GG Waffle.
Yep.
Yes.
And then here for managing file paths for us. And then as per usual, we're setting our theme to be theme classic so that all the plots going forward in our R session will be using this nice theming that we got here. All right. So now we're going to go through and pull in the data for us. Patrick, you want to take us through this?
Yeah, so when I saw the Waffle plots and I saw what Jared did, I immediately was like, oh, this is such a cool way to visualize target shares of NFL receivers on a team. So we went to Pro Football Reference and we snagged the 2019 receiving table. So there's the HTML. We read that in using the rvest package. And then again, using the rvest package, we're going to turn that into something that we can actually use and manipulate here within R. So we're going to create a REC receptions data set. We're going to pull in the table. From the per package, we use pluck is 1. I don't think we actually even had to do that because I think there's only one table on that page to pull in, maybe. I'd have to look. Pro Football Reference always has this kind of nice little thing where they redo the columns every 10 or 15 players. So we just basically, anytime it says rank in the name or rank in rank, that means they're adding that kind of the headers, the column headers. So we just delete that. And then from the janitor package, we use clean names, and that just takes the names that were pulled in from the table and basically puts everything onto lowercase, underscores things when there's spaces, just makes it a little bit easier to work with.
Yep.
And so there we see our nice little data set. Cool.
Alrighty.
And if we run glimpse, it'll show us that R has pulled everything in as characters. So we've got to do a little bit of cleanup here to make this work. So the way that we handle this is we identify all the columns that we want to be numeric. And we basically say, these are the columns, we want them to be numeric. And within the across function, which is saying across these columns that we've defined, 1, 4, and 6 to 19, from the readr package, we're going to parse the number. And we did that because there's a column in here called catch percentage, or CTH percent. Yeah, CTH percent. There it is. And you can see it's a character with this definable kind of percentage sign. So this function is actually a convenient way to just drop that and only take the numbers and turn them into a number. Otherwise, we'd have to use sub and we'd have to parse out the percentage sign and do a few extra steps. So this is a real clean way to do that, hence the name of this new data frame is called REC clean. And so there we are. We can see everything has now been turned into a numeric value, at least the columns that we wanted to be numeric values.
Yep. There we go.
All right. And now we're on to calculating the percent of target shares for each player on their team. So basically what we do is we take our REC clean data set. We're going to do a little bit of cleanup here. So in the aggregated season summary data, whenever you see a player that played on multiple teams within a season, instead of having a row that says that they played on, for example, Denver, and then maybe they played on Oakland or now Las Vegas, I suppose, it ropes them all together, and it basically just says, oh, this, there's Mohamed Sanu, right? He played on 2 teams in last year, and Kenyon Drake played on 2 teams. And so we thought, okay, like there's Nick Vannett, right? He played in Seattle for a few games, and he played in Pittsburgh after, I think, the 2nd or 3rd game of the season. So we just said, you know what, we're going to remove these guys. And it creates a little bit of havoc because it means that each team, for their target shares, you kind of miss 1 or 2. But that's okay because we're going to lump things together anyway for the purposes of making our waffle plots. We felt like we were kind of safe in doing this. So we filter those guys out. We're going to group by team, and we're going to say by team, sum up all the number of targets from the players you see. So this is basically going to give us the total targets that the quarterback or quarterbacks for that team threw. Then we're going to do another pipe, and we're going to group by now player and team, and we're going to create our target shares metric, which is the number of targets that that player received divided by the total team targets. And so that's going to give us that. And now, perfect.
Yep.
And now we're gonna use our ggpubr package here to make a cool little summary table. So I have target quant for target quantile, and I wrap that in the ggtext table function. And I'm going to create a data frame. Basically, I'm just taking that quantile, right? So this is the quantile of target shares across the team, across the league, rather, for the 2019 season. I'm going to wrap that whole thing in a data frame. So you can, oh, I think you missed the rows. Yeah, there you go. And we're going to wrap that all in a data frame, and then we're going to wrap it all into a text table. So if you were to just run that, it's going to open this nice little text table. And what we want to do is we want to take that text table and we want to put it onto this plot. So we're going to take our receiver targets and we're going to create a density plot of target shares for the season. So we're going to, X is going to be our target shares. We're going to use geom density. We're going to fill it in so that it's not just a line. It'll look a little pretty. We'll make it kind of opaque. The size is going to be specific to the line of the density. So it's going to thicken it up a little bit. And just to give some context, I'm going to set a vertical line with an x-intercept at the median of target shares. So it's going to be the basically middle value. And I use median rather than mean because you'll see that is a pretty right-tailed distribution with there's, a few guys like Michael Thomas or those guys who get absurd numbers of targets. And then there's basically everybody else. So we'll use the median value there. And then I use this annotation custom. And this is where I use ggpubr, is I put in this ggplotgrob and I put in that tidyquant table that we created right there. You can see in the little viewer window. And all I do is I define basically where I want it to be. So xmin to xmax, I want it to be that wide, and I want it to be plotted on the y-axis right here. And then I give some nice little labels. So target shares, Y is the density of target shares. The title is the distribution across the NFL, subtitled for the 2019 season, with the caption of the actual place that we removed the data from. So we'll go ahead and run that, and we'll drag it open. And there we go. So we can see the right tail distribution with the 100% up there at 0.336. I actually think it might have been Michael Thomas, if I remember correctly. And then you can see the median value came out in red, which is 50%, 50th percentile there, which is 0.042. And then you can see there's a huge lump of everybody else. So there's kind of like a few guys that are targeted a whole bunch on their team, a bunch of guys that are sort of the second receivers targeted, a little less, and then there's sort of everybody else who gets whatever they get in the game.
Yeah. I mean, that's not too surprising. You're gonna have your studs, you got your first stringers, but maybe not the studs, and then that's just like that's kind of how it goes.
That's it.
Cool.
All right. So where were we?
All right. Now we're gonna go through and create the waffle plot that we promised we were gonna make.
Yeah.
Yeah. So what we're gonna do is we're gonna go through and take the receiver target. So this is the same data frame that went into that. We're going to ungroup it because it was grouped by team earlier. We don't want that information to be kind of tracking along there. It kind of gets in the way. We're going to remove, we're only going to keep the San Francisco 49ers team, just a random team that we picked. Go through and subset to keep only the players and the number of targets they received. So we'll have a data frame that looks like this. So it's the player and the number of targets they've received. So this is really important for this next step that we do here, which is using uncount. So we've discussed count before, where you pass in a grouped data frame defining here's the or the columns that we want to be counting across, and it'll return a column named n, which lists the number of times whatever that subset was listed. This is the inverse of that, where we pass in what are the weights, and then it's going to undo that count essentially and list it as many times as n would have been. In this case, it's targets. So uncount weights equals target is now going to list player the number of times it was listed in target. And then we're going to do an FCT lump on player because we only want to keep the top, in this case, we only want to keep the top 4 players that receive the most targets. Otherwise, we're going to lump them into other. So that's, we'll run that. And now we've got a data frame that only has a column player. And as you can see, George Kittle is being listed the most times here. I think he was, he had 107 targets. So he's now going to be listed in this Team Rec data frame 107 times.
Yep.
But then any players down here like Marquise Goodwin, he's going to be lumped in with other because he was not one of the top 4 players or top 4 targeted players.
Yep.
That happened with that. So now we can go forward, and now we're going to create the actual waffle plot. I had to do some funky stuff here to try to keep the ordering together. So what happens was, as I take Team Rec, and then I convert the column player into a numeric value. The reason this works is because it's a factor, and so there is a number assigned to each of the levels. And so I wanted to try to preserve the order when I did the next step here, so I needed to convert that into a numeric value. We then throw it into the waffle iron function, which is, it's doing a lot of the back end stuff where it's kind of figuring out where do I draw each of the points. And so we're telling it we want to have 25 rows, and then the groups are going to be set by player. So this is now a numeric column that are listed n times. So 107 for George Kittle, and I believe that number was 1. So it's now going to list that up. And then I'm now going to mutate it to convert. So let's take a quick look at what this data frame looks like. So we have, let's just do a head of that. It's a little bit easier. So we have the X and Y position for the square that gets drawn there, and then group. And group is the actual player that we care about here. So what I'm going to do is I'm going to convert that back into the player's name using this chunk of code here. So we're going to use the levels here, which are the levels here, so the numeric values here, and use group to redefine that. So now it's going to, I'll just quickly run, because group's not defined. So group is a vector of length 400, and each time there's a 1, it's going to list the level 1 player here, and then so on and so forth. We're then going to convert it back into a factor because we want to keep the order the same when we plot it, using the same levels. Sorry if that's a little bit confusing. It's a little confusing to me too. So as you can see now, we've got Waffle DF, where we've got Debo Samuel listed as opposed to a number 1. And then we can throw this into our GM Waffle using very simple code. Yay! So the aesthetics, we define X as X, Y as Y, because that was created out of the waffle iron function. And we're now going to fill each one of those based on the group, which is the player name. We're going to use GM Waffle and use the theme from the Waffle package as well. And ba-boom. Here you go. So this is the San Francisco 49ers 2019 season player targets shares. So Debo Samuel received a lot. Same with George Kittle. Kendrick Bourne is listed here, and then Tevin Coleman, and then everyone else.
And the rest, yeah.
And the rest.
So the target shares variable that we created didn't need to be created to make this plot. We essentially just needed the count of targets.
Mm-hmm.
Where the target shares variable is going to come in is in our Shiny app, where we include a table that people can then see all of the players' data and information.
Mm-hmm. So we're gonna jump over to the Shiny app, but in order to do that, we're gonna need the data that we just generated throughout this process, and so I'm gonna save it as an RDS file. Using this, this is the object I'm trying to save here, and then this is the path to it. They always end with a .rds at the very end, and this is just the long path due to the file structure that we've got going on for TidyX. So we'll save that, and we will jump over to our app now and explain how that thing is structured. And so we've got the library Shiny, which is what you need to be able to create your Shiny. Use the library Tidyverse because that's how our brains are working with formatting the data, and then the library Waffle, which we're going to be using for creating the plot outputs. Then we've got this source bit here. So I wrote a helper function, or a function that we're going to use later on. So we'll just kind of skip this. But what this is doing is it's going to execute this script for us in our environment. So this is a pretty common way for people to bring in external scripts and execute them. We're then going to load in that same RDS file that we just saved so that we can then use it in the Shiny app. Our UI is actually relatively simple in this situation here. So we've got the sidebar panel, which is going to show up on the left-hand side of the Shiny, where we're going to allow the user to select the team that they want to look at. So that's how we're organizing it. So the input ID, which is going to be used on the server side, is TM for team. We're going to set the label so it's going to show up above the selector as team. The choices that the user has are going to be the unique teams that exist, so all 32 teams. We're not going to pre-select one, and they cannot select multiple teams. So we haven't set it up to do that. If we wanted to, we could have. And then there's this download button that'll generate and allow you to download a PDF of the data based on the team that you selected, if you so choose. And then the main output, which is now on the right hand side of it, we're going to be displaying the Waffle plot and then a table showing the player statistics for the team. So this is our UI part of the Shiny app. It's relatively simple. And then we'll jump over into the server. Do you want to take us through this one, Patrick?
Yeah, so the UI is explaining what we're allowing the user to do, and the server is going to do what the user says it wants under the hood. So we build the server based on a little function here with an input and output value. We're going to first need, obviously, data. So we do this by creating this object called Waffle plot. And it's a reactive data frame. And it's reactive because it's reacting to whatever the user defines when they go to use the web app. So within reactive, we're saying we want to get this data frame called team REC. We're going to use REC targets, which is what we built in the previous script. And we're going to essentially do what we did in the previous script. Basically, it's all just wrapped within this server. And so sometimes people look at Shiny apps and they're like, oh, there's so much craziness going on. The way that I always do it, the way that I did this actually, is I just literally plot it out for one thing. And then I think about, okay, if I was going to let someone manipulate this, how would I do it? So it's pretty much the same information. Where we previously had filter team equals SFO, we're now saying filter team equals input $team, which we defined in the user interface where we said the user can select TM. So we're going to let them select the team, and then everything else is the same. We select the player and the targets. We uncount the targets. We mutate the player. We create a mutate player equals FCT lump, so we get the 4 top receivers based on targets. And then we created another data set in here, Waffle DF, where we take that team receptions data frame, and we do exactly what Ellis described at the end of that previous script, where we're converting them to numeric. Then we're putting them into our cool little waffle iron function, which makes that long data set of counts based on the player. And then we're turning those factor numbers or factor values back into the actual player names. And then we finish by making our output of this nice little ggplot geom waffle that we created previously for San Francisco. So that's one piece of the server-defined function. The next piece is that we wanted to create a table, and this table is a way for people to extract the data and not only see it visually, but also get some information. So the table works the same way. We take our receiver targets data frame, we filter by the input that the user asks for, and then we select a few of the columns. So we're going to select the player, the position that they play, because you could have tight ends, receivers, running backs, fullbacks. We're going to select the number of targets and receptions that they made, and their catch percentage, so how often they caught the target every time they were targeted, and then their target share, so how frequently this player was targeted relative to his teammates in that season. And we're going to then create our outputs here. So our output is waffle plot. So Ellis had defined that up in the top in the user interface, where up in the user interface, we basically specify right there, we say, okay, we're going to let the user select in the sidebar which team they want. And then the output that we want is going to be a plot and as well as a table. And so the output ID is waffle plot. So if we go back down, you'll see that we said output $waffle plot. What we want outputted is that waffle plot that we built. And then for the output $player table, we want to render the table as that output a $player underscore table. And we put those as render plot and render table because, again, we want to allow these to be reactive and interact with the user based on what they're specifying.
Mm-hmm.
Yep.
Cool. And then the final piece of it, which we kind of briefly went over, was the fact that we're also going to allow the user to, once they've selected a team and they're like, oh, I want to show this off to my boss or something like that, they can then generate and download a report just at the click of a button of download that PDF button. So earlier we discussed how we were sourcing in this app helper.r script. And so we'll hop over to that and I'll quickly go through and explain that. I'm going to kind of keep it a little bit at a high level because it can be a little bit funky. And maybe later on we can go through this in more depth. But we're going to need the library rmarkdown because we're going to be using Markdown to generate the report. Create several temporary files. So this is the receiver report Markdown file that's going to be converted into the PDF. I also create a PNG and an RDS for the table and the plot. I'm going to save the plot in a temporary file. So that waffle plot that we generated, I'm going to save it in a temporary file so I can use that inside of my report. And then I'm also going to save the table as an RDS so we can source that in later. I create the header. So this is like, imagine you're creating a markdown, but this time I'm like kind of programmatically typing it out for it. So I'm creating the header there. So it's got the title, 2019 wide receiver distributions for, and then the team name that gets passed to it. And the output is PDF. Next, we have the body of the markdown there. So I've got a little bit of background explaining, where we got the data from, what the report's showing, very high level sort of information there. I've got, okay, now I'm going to do the waffle plot. So here is, it's going to be creating a path to the temporary file where I saved the plot to, and then I'm also going to convert that table into a cable using knit cable and set it to an as character, so that it's going to look like a markdown table at this point, and I'm going to drop that into my body. And then I'm going to write all these lines. So this is just character text. It's going to write it all into that temporary receiver report markdown file. And then I'm going to tell rmarkdown, convert this into a PDF for me with this line here. Mm-hmm. A key part of this is the output file equals file. So that is allowing the user to then define how the name that they want it to be saved as. And then this is just some cleanup, removing the temporary files that I created because I don't think we care about keeping those. So this was inside of a function called generate report. And so this is what allows it to be really flexible, is I am able to pass the values to it in the file name, and then it handles the backend stuff for me. But what really is doing the download is this download handler function from Shiny. And so this is where you define the file, a generic file name that you want it to be saved as, the content, which is actually what it's going to execute when it tries to save it. I'm passing in the team name, the waffle plot, ggplot, and the data frame that we want it to be saving as. So let us run this app. Make sure, I don't think I changed anything. Yeah, sure, save all that, whatever. And so now we've got our or our Shiny app. So there we go. So we were a little bit zoomed in earlier. So this is for New Orleans. So it just by default selects the first team it sees in the data set here. So this is for New Orleans. So you can see like Alvin Kamara is listed over here on the left. Then Jared Cook, Michael Thomas with his big share of receptions.
The lion's share.
The lion's share, more than any like of
That's insane. Look at the drop off, 34% and then 18% to the running back, which is interesting. But yeah, amazing.
So we've got all these players. You can look at any team. So let's like New England. So like Jacoby Myers, James White, Julian Edelman. So you know their friendship there. Philip Dorsett, and then all the other teams. I don't know. Let's just select another one. So Carolina. You can see the shares there. Christian McCaffrey getting a big chunk of receptions there. But so now you say we want to look at or download and hand off the PDF to our boss or something. So now we've got this download PDF. So now it's going to execute all that code we had in the back end. And now we've got this nice PDF here of the report itself. So everything we just saw in the Shiny is right here. So we can save this and email this off to our big boss and go, hey, here's the results that I looked at when I looked at the Shiny app. So the Waffle plot right here and the same stats. And so you can totally build this out however you want to, explore it, have some fun with it, and do that.
There you go.
So
that's Waffle plots.
That's Waffle plots. That's Shiny. That's downloading stuff. We covered a little bit, I think, in this episode.
A little bit of everything.
Yeah. So there you go. So I guess we'll just call it now. So thank you all for listening. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSPPatrick. You can find both of us on Twitter at Tidy_explained, or you can hit us up with questions, comments at Gmail. Our handle is tidy.explained@gmail.com.
Sweet. All right. Thank you, and keep on exploring your world.
Thanks.